Okay, so good evening all. Nila, can we go through a small intro about you?
Yes, we can. So
Yeah.
about myself, I'm Nilay Dalal from Ahmedabad,
Okay,
and I belong from Nagpur, Maharashtra.
okay,
Currently staying in Ahmedabad. So I did my bachelor's from mechanical in 2017, and after college, I initially started 2 years as a production engineer,
okay,
and currently working in US MNC Milacron India Private Limited,
okay,
which is a OEM of injection molding machine.
good.
So we supply injection molding machine ranging from 50 tonnage to 4,000 tonnage to the plastic making products to the customers.
Okay,
So my role over there is to design the toolings and fixtures over there for the various assembly processes of the injection molding machines, and to do concept generation, 3D modeling, prototype, use GD&T concepts, release technical drawings, working in the PDM Windchill software,
okay,
check-in, checkouts, engineering change requests, engineering change orders,
okay, good.
uh, starting from the means concept to the final product, unless and until it is working functionally.
Okay, perfect. So, do you have any background of design or any knowledge regarding any design
Yes,
tool?
yes, design tool I do have.
Hmm.
Initially, I started with the AutoCAD.
Okay,
Then, after joining this company, I learned more in depth with the Creo software and with the Windchill software. I
oh,
know I know basics of CATIA. I know Sketcher command. I know part modeling command. I
hmm.
know assembly command.
Okay, good.
Yeah.
So, have you done some training or you learn by yourself?
No, I haven't taken any training.
Okay,
Usually, I do watch the videos from the YouTube.
okay, good. Okay, thank you, Nilay.
Yeah. Thank you.
Said,
Good afternoon, sir.
good evening. Yes, Said.
Sorry, good evening, sir.
No issue,
Yes,
no issue. Yes.
yes. Actually, I don't have any design related experience in my past.
Okay, no issue.
Actually,
But
I am a
hmm,
I am a lecturer
okay,
in CBSE as well as state board
okay,
for a
okay,
math subject, right?
okay.
And I have completed my bachelor's degree in mechanical
Hmm,
in 2020.
okay.
Yes, and I live in Nasik, Maharashtra.
Nasik, Maharashtra. Okay, good.
Yes.
You have any, okay, as you mentioned, you don't have experience, but do you have any knowledge in design, any design tool,
No,
AutoCAD,
actually.
SolidWorks,
I
ugnx,
know the
anything?
tool
Hmm,
related to design, right?
hmm,
Yes, SolidWorks, CATIA,
okay,
right? And their domains, plastic, sheet metal.
okay,
Yes, but
okay.
I
No issue.
not an hands-on experience on that.
Okay, no issue, no issue. Thank you, Said.
Thank
Sanyog,
you.
good evening. Can you hear me? Hi,
Hello.
Sanyog, can you hear me? Yeah, hi.
Yes, sir.
Can you please introduce?
Sir, I am from Pune. Actually, I have completed my BE in
Sanyog,
mechanical.
your voice is not clear. Voice is not clear.
Hello.
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 Yeah, yeah. Could you please speak little bit loud?
आवाज आ रही है क्या, सर?
Yeah, yeah, yes, yes.
आप पास में 2024
24.
completed. Yes.
Okay,
I belong from Buldana, Maharashtra, in Maharashtra.
okay,
Yes. Currently, I have no experience of any industry or anything.
okay. Anyone wants to share screen? Ashok, Ganesh, Raja, quickly, quickly. Chinmay, Jayant. Doubts you can share. Otherwise, we can proceed. No issue. If you have any doubts, if you want to share your screen, otherwise you wants to share your file, please share. Is there any blocking point? Need any help? Wants to share your file, working file? Jayant, Chinmay,
सब क्लियर है सर.
Okay. Ashok, all clear? Done with the close volume?
Yes, sir.
Okay, let's proceed then. Is it visible now?
Yes.
Yes, sir.
Okay. So this is a complete product in new window. If you have any doubt, you can directly unmute and you can ask your doubt. Okay. Don't wait that I will stop, then you will ask the questions. No, you can directly ask. Okay. So here we have master sections. Raja has defined some master section. So let me explain what is this. The upper curve, this one is the leather.
Just a minute, sir.
Yes.
Can you
Okay. So what is master section? Okay. Suppose this is a part. Okay. This is a part on which, let's say Nilay, you are going to work on this part. Okay. But you have one team lead. There will be one team lead. Okay. Now let's
okay?
consider Ganesh is a team lead. Now Ganesh is having at least 4 to 5 member in his team who is going to work on the complete project. Here you have one part. On the next side, in yellow color, you have one structure part. Sorry, in yellow color, you will have the structure part like this. Third part is your grill part, speaker grill. Fourth will be the, let's say, the armrest of the door. Yeah, you know the HMI over here. You have some switches over here.
Yes, yes.
Okay. So, and let's say again you have the map pocket. Let's consider this as a map pocket. Okay. This will be your map pocket. Now, so how the complete team will work on the complete project. Okay. So how you will define, let's say Nilay is working on the yellow part. Ganesh is working on the, oh, Ganesh is a team lead. Okay. Ganesh is a team lead. So no issue. We will not consider Ganesh for now. Let's say we have Biradev. Biradev is working on the armrest. We have Ashok working on the speaker grill, and we have Chinmay working on the map pocket. Okay, and what is the role of Ganesh now? Now Ganesh as a team lead, he will define how will be the parts and how it will assemble on each other, and how the complete assembly will be pre-assembled over here. You will have pre-assembly like this, and you will assemble the complete door panel assembly. Let's call it a sub assembly. Okay, this will be a sub assembly for BIW. You will bring the complete sub assembly of door panel and you will assemble it on the BIW like this. Here you will have the sorry. Here you will have the BIW like this, the metal structure on which you will have some beads for the stranding and you will have some holes for the fixation like this. Okay. Tell me on which direction you are going to assemble the complete assembly. So how to decide the directions? Can you see the compass? We call it as compass. Z axis, X axis and Y axis. Okay. So right now just consider we will going to assemble the complete door panel assembly on the BIW in Y direction. So this is Y direction in this side. So let's consider this as a negative Y. So I will push the complete assembly on the BIW in this direction, negative Y direction. Okay. Now this direction is okay for me, no issue. So Ganesh will decide, okay, everyone, we are going to assemble the complete part. Then we will assemble the sub assembly of door panel. It will be a assembly, top assembly on the BIW. Okay. Now for the assembly, we already have one strategy. Okay, we are going to use some clips which we will receive from the vendors. Okay, tell me, will you design that clips or it will be a standard part?
It should be a standard part.
It should be standard part which we will collect or buy from the vendors. Okay, I have shown you the clips. Okay, now so what is the use of master section then? If you see over here, so what is master section? Okay, so master section we already done. Okay, we will again repeat this topic in next project, no issue. But in master section we will define the fixation strategy, how this part is going to assemble on the next part, how will be the trim. What is this? Okay, for new guys, I think you don't have idea what is trim. Trim word we will use for two components. It can be a fabric, it can be a leather. Okay, we will call it as trim, trim. Okay, it can be fabric or leather. Okay, so what is this? Fabric means it can be a cotton, nylon material, just like a seat cover. Leather means it will be a little bit thick as compared to fabric. So leather thickness can be 4 to 6 mm. Let's say fabric thickness will be 1 to 2 mm. Okay, we call it as trim. Okay, just keep in mind trim word. Whenever I'm using trim word, it will be related to fabric or leather. It's not the command. Okay, the in catia also we have the command trim command. Okay, but that is different. So what is this? We have this style input a surface. We have class a surface. Here input style a surface. Right click and this is a surface. This we will receive from the OEM. Otherwise, we will receive this from the styling team. So what is this? This is a style surface. Okay. Now we have to make a plastic part from this, but we have received some input that okay, so Ganesh has received some input as a team lead. He has received some input. You have to consider the trim wrapping of what was the thickness? Anyone remember? 2.7, I think. Ganesh, what was the trim
Yes,
thickness? Okay,
sir.
2.7. And what was the trim thickness plus padding? 0.6.
0.3,
3.3,
sir.
sir.
Sorry.
3.3. 3.3, sir.
No. 3.3 means it will be total.
Yeah, total 2.7
Okay.
plus. Yeah.
Okay. So this is 3.3. 0.6 plus 2.7. Yes, correct.
Yes, sir.
Okay. So trim of 3.3. It will be wrapping on the plastic part. Ganesh has received this input. So what is 3.3 then? It will be a trim thickness. So what will be the trim thickness? Trim thickness will be the fabric or the leather will be of 0.6 and this will be the foam padding. What is foam padding? Nilay, do you know whenever if you purchase any shirt, formal shirts from Raymond or any branded company, okay, they have one cardboard inside the shirt and on that cardboard you have the thin foam. Have you ever checked, Nilay? The
Yes,
thin
yes, on the
foam.
collar.
Yeah, on the collar or inside the pad, that cardboard. That we call it as foam padding. Okay, that is a foam
Okay,
padding.
okay,
2.7 thickness will be that foam padding, and this is
okay,
a leather thickness or the fabric thickness. So this is a
okay.
combinedly, the combinedly thickness will be 3.3. Okay, and so what is the use of this one? We will consider this thickness to define the A style of plastic. Okay, now let's. Everyone knows what is A style and all.
I am not aware.
Okay. A style means the surface which will be visible. Suppose you are purchasing any vehicle, any four wheeler, let's say BMW Audi. The surface area which is visible to you as a user, as a owner of that car, or a passenger or driver, that will be A surface, class A surface. We call it as class A surface. Clear everyone? New joinees?
Yes.
Said, clear? If it is not clear, you can directly ask, okay, sir, it is not clear to me.
No, sir. Please repeat this. A
Please repeat.
class.
Okay. The A class means, class A surface means the surface which is visible to the user. Let's say you are the driver. Okay. You are just driving a car. Tell me, can you see this? Can you see, can you touch or see this surface? Yes or no?
Mm, yes.
Okay. Dassault is working on it, but how will be AI? I will explain this in another session. Okay. We will first focus on the project. I will explain how AI is integrating in CATIA. Okay. If even though if you search on the YouTube, you will get idea how AI will be in CATIA. Okay. We have some videos. Okay, coming back to master sections. Now you got idea, sir. We have multiple parts. We have leather trim. Now we have this one. Now, sir, we have the trim thickness. 3.3 will be the total one, and the leather will be of 0.6 and padding will be of 2.7. So these sections we have drawn with help of sketching tool. Okay, we have sketching tool. We will learn this from, we will learn this in trainings. Okay, right now I will just explain. Sir, in master section, what we will do, Ganesh as a team lead, what he will do, he will define the strategy, how parts will be overlap, how, which type of fixation we will use, where should we use the welding bosses, where should we use the screw bosses, where should we use the dog hose snaps, the locator pins, this fixation towers and all. Okay, so in master section here you can see, in master section we have defined the screw bosses. And if you notice, can you see this one, the upper portion, this is a leather, we have considered the leather. So what is the thickness? If you measure, so what is the thickness? Measuring tool, the thickness edge only, this till this one. What is the thickness?
Point
Point
6
zero point
mm.
0.6. From this till this one. What is the thickness?
2.7.
2.7. Same we have noted down. 0.6 plus
Yes.
2.7. So suppose the blue one is a plastic part, what we are going to design on that plastic part, we are going to wrap the leather. Okay, so if you notice in this master section, if I show you the leather will be something like this. Hello, no background noise, no background noise, please mute. The leather will be this one, yellow portion will be leather, the thickness will be 0.6, I think, yes, 0.6. Okay, and on this leather we have foam padding of 2.7. Okay, so this will be the leather and this will be the ink in white color. Okay, I will use white color. This will be the foam padding. 1, 2, 3, 4, 5, 6, 7. Are you getting? The white one will be the foam. So, sir, how we are going to fix the leather with foam padding on the plastic part? We will glue this one. Okay, with some method we will glue this one. Okay, we'll discuss that techniques later. Okay, just assume that we will glue this leather on the plastic surface. So what will happen? Any idea what will happen if we glue? What is the purpose? What can be the purpose? Why we will glue the leather on the plastic?
fix
Maybe to
this.
join permanently on that plastic.
Yeah, but what is the reason why we are adding unnecessary? We are the plastic part. Why unnecessarily we are adding the leather on the plastic?
Cushioning effect.
Good cushioning effect and
Comfort.
comfort. Okay, no, see comfort. Okay, cushioning effect, comfort. Okay, Said, as you mentioned comfort, we will consider the comfort word where occupant will occupant can touch, means occupant can will means he will rest body part. Let's say this seat.
Okay, okay.
In
Mm,
seat we can call it as comfort, but we are talking
yes.
about the door panel. Okay, so here we
Mm-hmm.
will not consider the comfort. The
Comfort,
first
yes.
option is okay, cushioning
Cushioning
effect
effect.
is okay. The second,
Uh,
again second point,
Light reflection.
perfect, light reflection to reduce the light reflection. But any replacement, if suppose I don't want to add the leather on the door panel, how can we avoid the light reflection? Sanyog, can you please unmute? I can't see your chats. I can't see your chats. Okay, please unmute and answer. Yes, any replacement. Suppose I don't want to use leather. What you will use?
Polythene, rubber material.
Rubber material you can use. Good. Okay, let me close this topic first. Can you see? If you notice, sir, here we have maintained the thickness. Here we have maintained the 0.6, and after 0.6 we have maintained 2.7. So why here we have the minimum thickness? Because this is a turning portion. On turning portion, the foam padding will get compressed, yes or no? It will compress.
Yes.
Yes.
Here again we will compress. Here we will again it will compress. And from this portion, this till this one, we will use glue. It will be glued, highly pressured glue. Okay, same like this till this one we will glue here. So on complete portion we'll glue it, no issue, but in this portion we will have some compression of foam padding. Okay, now tell me, I think this point is clear. Nilay got the rough idea what is the use of master section?
Yeah, little bit.
Little bit, no issue. So you have not done the basic, that's why. Okay, so what Ganesh will do, Ganesh will define the master section on which places where you have the interfaces mean the fixation, the other parts or overlapping. Can you see on this portion we have drawn the master section? Why? Because here we have defined one fixation, also we had shown some doghouse. Here you will have a cross section of this circle where we will have that clip. Okay, and this side we have shown how will be the plastic part and how will be the trim wrapping. Okay, so
Uh,
we
ju-
will, yes.
I just wanted to know that initially you told that master sections are shown on the place where fixations is to be done, right?
Yeah,
As I
yes,
understand,
yes,
if
yes,
I'm correct.
yes.
So I would like to know that how these fixations are being derived and defined.
Okay. So we have multiple projects. Okay. In past, we have done multiple projects. Okay. Clear? In
Okay.
past, we had done multiple projects. We have benchmarkings. What is a benchmarking? The methods, what we have learned, the past, from the past mistakes. Okay. We had defined some standard fixations. Okay. We had designed some rules for the fixations. Mostly for the, if you want to assemble any part with the BIW, we have some standard fixation, we have some standard vendors. Okay, mostly if you want to assemble a plastic part on the another plastic part, we will use hit stack. For hit stack we will use we will use welding bosses. So here you can see we have the welding bosses. So standard fixation we already have from our experience, from our last projects. So we will take the reference from it and we will design accordingly. So we'll now how will you define the fixation? We have some technical, what we can say, the technical reasons why and how should be the fixation and how to define the position of the fixation. Okay, these points we will discuss later. Okay, Nile?
Yeah, understood.
Okay, and so what is the second benefit? Once Ganesh define the complete master sections, Ganesh will share this master section with our team member. Okay, now what the team member will maintain? They will maintain the master section. They have the A surface. If I take the section over here, if we have the section on this position like this, okay, like this. So here you can see the pink surface is matching with this section, outer line. Now, after that, we will offset it by 0.6. After that, suppose on this part, let's say Ashok is working. Now, Ashok has the master section, also Ashok has the pink surface. He doesn't have the green surface, okay? No green surface, no blue surface. Only he has the A surface and the master section, that's it. Okay, so what will the process? Ashok will maintain and will create a new surface which will match this line. So with help of this master sections, Ashok will create a new surface for the plastic. So how it will be plastic? Just now we discussed. This is 0.6 from this surface till this one. This is 0.6, and after this surface, this is 0.7. So Ashok will offset this surface inside by 3.3 mm to get the A style of plastic part. This will be the plastic part. Sorry, in green color. This will be the plastic. This will be the plastic part. Clear? So
Yes,
accordingly, Ganesh will share all master section with his team member and will inform them, okay, you have the A style of all parts. Now you can you can start your 3D, but please maintain the master section because Ganesh has done the complete assembly story considering the MTD, means tooling direction and all.
just a doubt, sir.
Yes,
You told that we will offset
the surface.
considering the surface considering
Yes,
the benchmark of the foam, right?
not the benchmark.
Uh,
We have the inputs
Sorry,
for
inputs,
the trim
inputs.
thickness. Yes.
So you told that we will offset by 3 mm,
Hmm.
right?
3.3 mm.
3.3 mm. So how
Hmm.
it will be offsetted where the radius gets started and where the narrow sections are there?
So this portion we will cover in your trainings.
Okay, so
Okay.
okay, thank you.
Yeah. So
Yeah.
these are the project discussions. Okay. So I have just given the basic idea. What is now the master sections are visible on your screen. So you should know what is the meaning of master sections. Now you know trim, you know leather, you know foam padding, you know the master section word, you know the A style, class A style. Okay. Done. Okay. If you want to see the actual part, here you can see the actual part. Once you I think we have completed the closed volume. Here you can see. So what is closed volume? Closed volume means the plastic part. There is one method, we call it as closed volume. Sir, in closed volume, what you will do? We will create A surface, we will create B surface, we will create C surface. After that, we will get this result. Define. This will be our result. Let's hide other. Where is the A surface? Hide it. This will be our result of closed volume. And after this, here you can see some operations, we call it as Boolean operation. So in industry, you have to follow the same methods. Okay, we have some rules you have to follow. So if I show you, this will be the result of plastic part. This will be your plastic part. And Once you're done with the plastic part close volume, you will have to define the fixations like this. These are the fixations on the green part. So this is a reference part, only for reference. Okay. You have to design, rebuild the 3D like this, and you will have to add this fixation on your blue body, this one, the blue one, what I have created on my side. Okay, so what is this green features? We call it as B features. What is this? These are B features, B side features for the fixations. Okay, I think Nilay, you are from plastic injections. So, okay, so I think you don't have the idea about the heat stack and all. You have the idea?
No, no,
No, okay.
no. Actually,
It's come
basically, we
under
are
assembly.
yeah,
Yeah,
yeah.
no issue. But you know what is MTD, what is parting line, what is shut off angle. I think you should have the ideas.
Frankly speaking, sir, I'm my background is from tooling design engineer,
Huh?
and even I know just where you can say at the starting of basic of plastics only,
Okay.
thermosetting, thermoplastics,
Huh?
like that. I don't know the more in detail what you're talking about.
No issue, no issue. No issue. Okay, Said, clear? Whatever we have
Yes,
discussed
sir.
till now, are you getting?
Yes, sir.
Vinay, Arvind clear, Abhay clear? Everyone, any doubt?
Yes, sir.
Clear. Okay. Abhay, Arvind clear? Yes?
Yes, sir. Yes, sir.
Perfect. Now, yes. Now tell me on which topic should we proceed? Raja, Ashok, Ganesh, quickly.
How to create the feature.
How to create feature? Ganesh, I think here just you have to follow the remastering. Just you have to follow remastering concept. Yes?
Okay.
Okay, but if you want to discuss how you will find out the lifter direction, slider direction, that point we can discuss. Yes, Prashant, any
Okay.
doubts?
Okay.
You tell me
No,
on
sir.
which topic should we proceed today? Jayant, Chinmay, Ashok, quickly. Raja?
Yes, sir. Sir, actually, I am doing, sir, a doghouse
Hmm.
uh, in that part, sir.
Okay.
So, sir, actually, I am confused in, sir, the lifter direction, sir,
Hmm.
and the MTD and the MTD direction. When I put a assist system
Hmm.
with respect to MTD and
Okay.
give another x-axis with respect to lifter direction,
Okay.
uh, actually that not create a 90-degree.
Okay.
So
Means okay. Okay. I think last time you also asked the same question, sir. If the lifter and the MTD is not in 90-degree, how to put the
yes, sir.
access system and how to start? Can you please
Yes, yes.
share your file? Please rename your file underscore Raja and please share. Okay.
Uh, okay, sir. Okay, sir.
Right now, can you share?
Yes, sir.
Please share. Just share in our data sharing group. Okay.
Sure.
How to find lifter direction. Okay. So this topic we will cover in the new file. Okay. What I'm receiving from Raja. Okay. Ganesh.
Hello, sir.
Yes, Jayant.
Yes, sir.
सर जो मास्टर सेक्शन है सर आई क्रिएट अ मास्टर सेक्शन
Hmm.
एंड सर आई सॉ द वीडियो फॉर मास्टर सेक्शन यूट्यूब सर
Hmm.
तो सर हमने जो आपने जो मास्टर सेक्शन में जो ट्रिंच है उसको आपने एक्सटेंड किया था सर उसका मेन एक्सटेंड करने का क्या रीजन था इन
Oh, the
मास्टर
endpoint.
सेक्शन
The endpoint.
या एंड पॉइंट सर
This one I think. Where is the sections? Input. This sections. This one.
हाँ यस सर दिस वन एंड सर जो नीचे कर्व आ रहा है सर उसमें भी सर इन द बॉटम साइड सर
Yeah, on this side.
या दिस साइड यस
This will be for gluing. Okay, we have some standard. Okay, we have some standard dimension. This should be 10 to 15 mm. Okay, Jayant?
सर सर मेरा क्वेश्चन ये भी था, जब हम इसको
Hmm.
सर इतना ये एक्सटेंड करेंगे,
Hmm.
ठीक है, आई थिंक वी कैन क्रिएट प्रोडक्ट
Hmm.
फॉर दिस मार्क सेक्शन, देयर हम इसको सर इतना एक्सटेंड करेंगे तो आफ्टर दैट सर फिटमेंट में इशू नहीं आएगा क्या?
No.
Okay.
Here you can see, even though you have the master section, can you see after this trim we have fixations. And
Okay.
if you notice on the complete periphery we have the welding bosses,
Yes,
but
sir.
from boundary we have left some space. If you measure what is the space between this any geometry surface only, from this till this one, 15 mm. Got it?
Okay, sir. Got it, sir.
So if you notice, can you see there is no fixation which is in contact with the extreme edges. See, we have some gap. Okay, and
Okay.
Jayant, suppose if you are defining the master section, I think, I don't know you have idea or not. Previously I mentioned, please maintain these lines uniformly. Okay, in all master sections, let's say how many master sections I have, 1 2 3 4 vertical, 4 master section. So in all 4 master section, the length of this edge should be constant, the length as well as the angle. So which angle? If I draw the line tangent to this one, this angle, let's say x, okay, x degree, and the length L, this should be constant in all 4 master section. Okay, tell me, if you keep this 10 degree and in next master section if you are changing the angle, or instead of 10 you are keeping 45 degree, will it be uniform? Can you imagine how will be the part? Wavy?
Uh, yes, sir. Waviness आ जाएगी sir इसमें.
Waviness. Okay,
Yeah.
so that's why it should be uniform. Even though if you are adding some fillet value over here, keep it constant. Okay, for upper portion as well as for the lower portion. Okay, if you are maintaining the parting line over here, keep it constant. Okay, then only you will get the uniform sections. If your sections are perfect, your A
Sir,
style and your 3D will be perfect.
एंड सर सेकेंडली सर ये हमको प्लास्टिक पार्ट में यदि हमको इसका यदि थिकनेस कम करनी है तो हम ग्रेजुअली कम करेंगे, करनी हो तो, इफ
Where?
आई एम नॉट सेइंग कि इस पार्ट में, एक मेरा क्वेश्चन है सर नॉर्मली, यार हमको सर कोई ऐसा पार्ट मिलता है, जिस पार्ट की रिक्वायरमेंट होती है कि वी कैन वन साइड इज 2 mm एंड अनदर साइड इज 1.5 or 1 mm, so how can we sir, यार आई थिंक जो 2 mm से 1 mm से जो प्रॉपर ग्रेजुअली कम करेंगे कि सडन चेंज होता है वो
No,
पार्ट?
no, it should be gradually. Remember we had done a close volume for the A pillar.
यस सर, यस सर.
Remember there in sketches we have maintained the
आई नो सर, आई गॉट इट.
sections. Yes,
या आई गॉट इट.
non means the, I think in that part we don't have the uniform thickness.
या आई गॉट
This,
इट, समथिंग समथिंग.
okay,
ओके.
suppose this is A surface,
या
here you have to maintain 2.5, here you have to maintain 1 mm, so you will go like this.
ओके सर, गॉट इट.
Okay, Raja shared the file.
Hello, sir.
Yes, Ashok.
Sir, means purpose of gluing to provide means to tightness of fabric to plastic part.
Plastic, yeah.
It is correct.
Yeah,
Okay.
perfect.
सर आई
Sure.
हैव टू आस्क वन डाउट.
Yes, Sachin.
सर हम लोग असेंबली में जब सेक्शन लेते हैं सर,
Okay, in assembly section. Okay, in product. Yes.
वो सेक्शन मतलब हमको पूरा व्यू चाहिए तो कैसे करना है, उससे बाहर कैसे निकलते सर सेक्शन से?
Sorry, I'm
कट
not
सेक्शन
get.
रहता है उतना वही दिखता है, मुझे
Okay,
पूरा
okay,
व्यू
okay,
चाहिए.
okay, okay, okay. So suppose we are in product. You are using this section. Yes, correct. Sectioning.
Yes, sir.
Now if you want to cut this part, here you can see the first tab definition, here you can see the cut, volume cut. Click on it, you can see. Okay,
Yes, sir.
now your question is how to come to
Revert
the
back.
original position, revert. Again click on
Yes.
this one, deactivate this one. Clear?
Yes, sir.
Okay.
Sir, file share.
Okay. Raja, did rename किया?
Yes, sir. Yes.
Just a question.
Yes, Nilay.
I think this is the assembly workbench, right, in CATIA.
Yeah.
So I would like to know that what means we follow. Do we follow top-down assembly approach or bottom-up assembly approach to make this part?
Good question. Anyone wants to answer? Ashok, Ganesh, Raja?
If sir either or, then I would like to know the reason as well.
Yeah, sure. Anyone?
Repeat the question, sir.
Okay, Nilay, could you
Sir,
please repeat the question?
Actually, my question was, what intent do we follow while designing this whole means assembly? Either we follow top-down assembly approach or bottom-up assembly approach. Generally, I understand that in top-down assembly approach, we make the product name and we make those products in the assembly. While in the bottom-up assembly, we generally bring the parts individually from the folders. So, which step we follow, top-down assembly or bottom-up assembly? If either or, then why only those? Question is this.
Quickly, anyone wants to answer?
Top-down assembly, because we are designing part in assembly with respect to the input, and we will be having a one absolute access system. We call that as a vehicle access system. So we need to refer that, and we need to check the assembly and other its counterparts, they are matching, or we need to maintain their gap and flush. So that's why we go top-down assembly.
Good, Prashant. Anyone else? Ashok, Raja, Ganesh, Jayant? Anyone wants to answer? Prashant Patil?
Same, sir. Same answer.
Same answer. Nilay, you got it or shall I explain?
I would like to means get to more in detail if you can.
Okay. See, let's take the same example. Okay, you have the BRW. Okay, Nilay is just let me know. You have idea
Yes.
regarding what is top down and what is bottom up?
टॉप डाउन में अपन क्या करते हैं कि कोई भी एक असेंबली का पार्ट बना के, मतलब असेंबली का पार्ट का नाम बना के उसके अंदर सारे पार्ट ड्रॉ करके उसी के अंदर असेंबली करते हैं. बॉटम अप में क्या रहता है कि एक फोल्डर रहता है, उस फोल्डर में हम लोग अलग अलग पार्ट बना के उसमें सेव करते हैं, एंड देन वी ब्रिंग दोस पार्ट्स इन द बॉटम अप मींस इन द असेंबली एंड वी अप्लाई वेरियस कंस्ट्रेंट्स ओवर देयर.
Okay, so your answer is 20% correct, 80% wrong. Okay, so what is top down and what is bottom up? In industry, every time we will use, in any industry, let's say automobile product, in any design industry, we will use top down assembly. Okay, so what is top down? Top down means, first let's discuss the bottom up. What is bottom up? Let's say you have one room, you have some space like a box. Okay, like a box, like this. You have some height, you have some width, you have some length. Okay, now you have to design something inside this box, but also you have to fix inside this hole. You have some holes on that, on all side, on top as well, on this side as well. Okay, this is the rear edges. I will draw in green, backside edges. Okay, now Nilay, you want to design something inside this box. Let's say you want to design a statue of Lord Ganesha. Okay, you want to design, you want to make a statue of Lord Ganesha inside this box. The height is, the height of that statue will be 25, or let's say 60 feet by 50 feet by 80 feet. Okay, tell me, if you want to design such a huge statue, we have provided some holes for what? Tell me, will you design from the clay directly, or will you create some skeleton first?
I think we will create for skeleton.
Good. So we are providing you some holes where you will fix your skeleton. Okay.
Okay.
Now you have the rods where you will lock like this. Okay, sorry, let me change the color. White. You will pass some rod like this. 1, 2, 3, 4. Okay, and first the middle one. Okay, I will just connect this one. Okay, now this is your skeleton. Now tell me, will you will you create this skeleton in this position, or will you do somewhere in space like this? Suppose here is a playground of the society. Will you create this skeleton over here on the ground like this? Okay, sir. This will be the first two, means this two. Then I will keep one vertical, means this vertical. Again, I will keep this two. You will create this skeleton over here, and will you bring the complete huge skeleton of 60 by 50 by 80? Will you bring this skeleton inside this box, and will you fix inside this hole? Will you do like this?
It is not possible at all.
Huh?
It is not possible. So we will create the skeleton as is shown in the yellow background
Inside
box.
box. Okay.
Yes.
So we call it as top-down assembly.
Okay.
Okay.
Which one in yellow box you told?
Yeah, the first one.
Okay.
This
Okay.
is bottom up. You are creating
Okay.
something over here, then you will bring over here. But while you are
Okay.
creating over here, you don't have any reference of this hole. What is the distance between holes? What is the height between these two holes? Width. Okay. What is the box width and height? You don't have. Correct. But you are creating
Okay.
something over here. Now, if you're bringing the complete assembly over here, now you are getting idea. Okay, these hole are not matching. Okay. What benefit you are
Okay.
getting in top down if you are creating inside the box? Which benefits you are getting now?
Generally, we boundaries defined,
Hmm.
constraints are defined,
Hmm.
and dimensions are defined, and overall picture of the means bodies we can get to know better, means skeleton.
Perfect. Got it? Everyone clear, Said?
Okay.
Yes, sir.
Vinay? Okay. So this is an interview question again. Okay.
Yeah, actually, this question was asked to me by
Hmm.
L&T recruiting team, so I just wanted to know more in detail.
Perfect. No issue. But you got the answer. Okay. Very simple.
Yes, yes, yeah.
Top down assembly. This is bottom up. Okay.
Uh,
Any doubt? Yes, Jen.
सर सर जो मोस्टली जो हम जो पार्ट डिजाइन करते हैं
Hmm.
कार के डोर पैनल एंड हुड हो गया अदर अदर थिंग हो गए
Hmm.
दिस इज आल्सो कॉल्ड टॉप डाउन असेंबली
What do you think?
आई थिंक दिस इज टॉप डाउन असेंबली
Perfect.
बट सर आई थिंक ऑल द कार पार्ट्स आई थिंक जो मोस्टली कार जो असेंबली होती है
Hmm.
टोटल ऑफ कार असेंबली
Hmm.
लाइक टॉप डाउन असेंबली आई थिंक सो है ना
No, see, the assembly is different, Jayant.
Okay.
We are talking about design.
Okay.
Tell me, your design, you're going to manufacture this green part in injection molding.
Okay.
Will you put the complete door panel BIW in injection molding for this part, green part? No.
No.
You will first manufacture separately, then
Yes.
you will assemble it. You will assemble all door panel parts on a structural part. That was the yellow part, what we have seen previously. That is the structural part which will have some clips which will lock on the BIW structure. Assembly is different. Don't mix up the assembly and the design. We are just now
Okay.
the example what I give on this one, skeleton and all. This is for design. Okay.
Got it. Got it.
Yes. Suppose again the same. This is done. Okay, any doubt on this point?
No.
No. Okay, good. Okay, now Jayant, let me clear your topic point. So, what is design? What is assembly? Tell me, there is one styling. There is one guy from the styling team. Let's say Biredeo. Biredeo is from styling team. Tell me, he's from the styling team. He wants to design the surface like this. So, do we have the absolute access system? Yes. Okay. So here we have absolute access system. If I click on ISO, this is my absolute access system. So this side we have the door panel. Okay. Now, if I take the top view, click on Z. This is a top view. Okay. Now where is the front view, front side of the car? This is the front side. Okay. So here we have one seat. Here we have the second seat. Okay. Here we have the gearbox. Here we have the dashboard. And here we have the steering. Let's say. Okay. Now suppose Biridev is from styling team. Tell me, Jayant, in which location Biridev should design the surface? See, we can't start our 3D without a surface. Okay. So we are waiting for the style. What we will receive from we will receive from Biridev. So Biridev wants to start the style for this part. Tell me, can Biridev start his style over here anywhere in space like this? Yes.
I don't know.
No. Can he design over here? He will take one axis anywhere like this in space. This is the axis. Okay. Now Birudev will inform us, okay, I had designed one style. Take this style and start your 3D. Tell me, if you take this style file and if you copy paste in your product, you have the absolute access system over here. And this is the complete architecture of the car or the seat. And once you copy paste the style file, what you have received from Birudev, the position will be here. Now, what you will do? It's not your mistake. Birudo should design his style in this position. Got it, Jayant?
Yes, sir.
And it should be with respect to the BIW what you already have, which will be common in your file. Sorry, in your file as well as the Birudo's file. Okay, this will be the BIW. Clear? So
Yes,
that
sir.
means Birudo will design his style. Then with respect to that style, you will design the 3D. That with respect to that 3D, you will design the fixations which will be fixed on the BIW. So everything you will do on this position, we call it as product position. What we call it as product position. Okay. Sir, then what is bottom up? Tell me. You're going to buy some clips. You know that clips just now we have seen
Yes, sir. Yes, sir. Yeah, got
this
it, sir.
type of clip.
Yes, sir.
Tell me someone has designed this clip, yes or no? Without design, you can't manufacture any part. Okay.
Yes, sir.
So you have this clip like this. Okay. So someone, let's say Suyog is our vendor. Suyog has designed this clip. Tell me, is it necessary that here is the access system? Okay. And Suyog has designed this clip and he has also manufactured this clip. Now he's your vendor. He's going to supply this clip. Is it mandatory that Suyog should design this clip and manufacture in this position? Is it mandatory? You're going to
No, sir.
use? No. Nilay clear, Said clear, Biridev, everyone, Suyog, Jayant, Akash, Ashok, Sachin, Shweta.
Yes, sir. Yes, sir.
Yes, sir.
Okay, so this is bottom up. Got it? Yes?
Yes, sir. Yes, sir. समझ गया, sir. I got it, sir.
Then, sir, bottom up, what which reference they have taken?
No need of reference. Tell me, Ganesh, if you want, suppose, tell me what you want from the vendors. What you want? Clips, screw, nut bolt, washers. Yes?
Yes, sir.
This thing you want from the vendors. Okay. Tell me, they have taken any access system, any reference. Do you have any blocking point? Can you use that screw? Can you use that clip in your designs?
Yes, sir.
Yes. What is important for you? The diameter, the pitch distance. What is the pitch of the screw? Yes. Is it of M5, M6, M10, M15? What is the diameter of the clip? It should match with your BIW. That is important for you. The access system and the other things, how Seo has designed that clip, in which position he has designed. No issue. That is not important. Okay.
Yes, sir.
Even though the switch box, what you have, let's say here we have one window. What is the purpose of this window? Quickly, what will be here? Quickly.
Speaker, I think.
Latch,
Sorry,
latch.
latch.
Handles.
We will have latch,
Let's.
locking,
Yes, let's.
locking, unlocking latch. Okay. So tell me, if suppose you are designing this latch, no issue. But if you are buying this part from the vendor, what will be important? The important will be the boundary. Yes, position is not important. Anyhow, we are going to bring that part from inside. We will put it from inside, and we will add. We will. Yeah, we have the screw bosses. We will add some screws. That's it. See, one. We have screw bosses. One, two, three, four, five, six. Done. No need of access system. No need of the proper position of design and all. Why? It is a standard part. If you want to design that part, if let's say you are working for audio BMW, if they are telling you no, we are not going to buy this part from the vendor, we are going to design separately. We are going to manufacture this part separately. It will be of chrome. Okay. Mostly the latch will be in chrome. So we are not going to take from any vendor. We are going to design. In that case, you will have to consider the latch in your master section assembly, and you will have to design where you will design in this position only. You will not design somewhere here. Got it, Ganesh?
Yes, sir.
Clear, everyone?
Yes.
Okay. Any other blocking point? Okay, we miss one point. So how to find out the lifter and slider direction? Raja, is this your file? No, this one. Okay, let's hide
Yes.
everything. Let's tool hide all access system. Hide everything.
Sir, check my sir, lifted.
This is your lifter direction. This one.
Yes, sir.
Unhide, unhide. Done. So is it okay or not okay? Just perform draft analysis. Double click, put it in material mode. Material is okay. The compass on this one. Select compass. Okay. Raja, tell me this face should be in.
Yes, sir. But
Okay, this is a dump file. Yes, this is a dump part. Okay. Put
sir,
it
actually,
in edge mode.
if I perform data analysis with respect to sir,
Hmm.
what I call sir, sir, this MTD I have give some angle, so that create the red patches. If
No.
I create,
Hmm.
if I did not give any angle,
Hmm.
uh, sir, lower the see the lower red patches is there at cross
Okay.
section. Yes, sir. No, no, at cross section, no, 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 that, no.
Shall I take the section like this?
नो नो सर आई थिंक सर वहाँ पर एक है रेड बैच नहीं नहीं वो वहाँ पर नहीं है सर
This one?
कट सेक्शन नहीं सर जो पार्ट है ना जो क्लोज वॉल्यूम
Latch,
हुआ पार्ट
यहाँ
हाँ
पे
रेड
latch A
फ्रंट
पे
में.
बोल रहे
हाँ
हैं,
हाँ
latch A।
ओके ओके.
वो बहुत ज्यादा हो जा रहा है वो
हाँ.
बाहर आ जा रहा है तो मैं एंगल दिया तो इसलिए वो ऊपर उठ गया तो इसलिए वो रेड पैच आ जा रहा है
Okay.
लॉग हाउस में
I got it. I agree that you have raised the angle, increase the angle, just to clear the front portion of the plastic part. Yes?
हाँ यस यस सर
Okay. Now tell me, this height is important for you, yes or no?
नो सर दैट हाइट नॉट बट द
Not
रीप्स
important.
हाइट
The rib height is important for you?
हाँ यस सर
Okay. So we will maintain this height. Okay. Tell me, these faces are important or for you, yes or no?
नो सर
Can you add or change the angle? This face is important for you. Is it important?
नो सर
Can you change the angle?
यस सर
If you change the angle, is it affecting your A style? Is there any sync mark issue?
नो सर
For tooling, you are just changing this angle. No issue. But we will maintain this face. Tell me, can you change this face now? Will you change this face?
नो सर
No. Why?
actually, that phase and with respect to the BIW.
Perfect.
So,
Your clip is going to rest on this face. So we will not change this face. Okay. Can you change this face little bit?
yes, sir.
Can you change this angle? Can you apply some small angle 0.51 degree just to
Yes, sir.
avoid this red portion?
Yes, sir.
Done. No issue. Got it?
Okay, sir.
So like this, you should think, okay, whenever if you're working on any part or any project or any product, just think like this, what is important and what is not important. If it is not important, you can leave it. Tell me, we are going to use leather wrapping. I will not think about the sync mark and all, but it is not, if if I'm not trying to avoid the sync mark, it's okay, no issue. Why? Because we have the leather wrapping. But technically, if as a designer, you should consider this one. See, we can cancel this sync mark. Let's say if I cancel the core out, tell me, are we going to avoid the lifter? Can we avoid the lifter? Yes. Can we avoid the lifter if we cancel the core out?
Yes, sir.
Yes, sir.
No.
No.
Yes or no? See,
Yes, sir. Yes, sir. We cancel the sync magna. We cover with our leather part.
hmm.
So if we cover with the leather part, so we can cancel core out.
No, then
No.
Raja, even though if you cancel the core out, can you reduce the tool costing? Can you cancel the complete lifter block?
No.
No, sir.
No. So even so anyhow, if you are using the lifter block, you can add this core out. It will not add any additional cost in your tooling. Got it?
Yes, sir.
Okay, now suppose you have a locator. Do we have the locator on this part? Uh, do we have the locator on this part? No? Okay. Let's suppose you have a huge locator of 2 mm like this. 1, 2, 3, 4. This is a locator. Tell me, will you reduce the part thickness? Will you reduce the locator thickness? Tell me, would you think about the sink mark? Can you, to avoid the sink mark, can you add any lifter or slider?
Yes, sir.
But will you add some cost in tooling?
Yes, sir.
No, Jayant, we have the leather wrapping from the bottom side. Got it? If you want to avoid the sink mark issue, what I will do? Any idea what you will do? Quickly, in 1 second. What you will do?
Sir, give me some draft for bottom side.
No,
We are going to provide a core out
n-
surrounding to that locator.
no,
Thickness.
no. Okay, sorry. I'm getting some confusion. If you are using core route, it is not possible to add core route on this ribs. Okay, the resting ribs. It is not possible. But if you have some issue regarding the sink mark, the best thing is, sir, I will add a doghouse. That's it. On doghouse, I will add the locator. This is, will be your core route on one side only. Got it?
हेलो सर.
Yes, Jayant.
सर आई थिंक द लास्ट टाइम जब हमने सीटिंग वाला प्रोजेक्ट किया था,
Hmm.
उसमें सर एक लिफ्टर था, जब आपने बताया था कि इसमें लिफ्टर में एक से लिफ्टर में ना आई
दो
थिंक ड्राफ्ट
दो
दे रखा
तीन.
था.
Hmm.
या सर हम इसमें भी तो ड्राफ्ट दे सकते हैं बॉटम साइड में, तो इशू है कुछ क्या प्रॉब्लम
Just
आएगी?
try to design how will you clear by adding draft.
ओके.
Okay, if you design the 3D, you will get idea what will the issue. See, adding lifter in one direction is okay. Adding lifter from all four direction will be different.
ओके 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 ओके.
Okay,
समझ गया सर. ओके.
got it?
या सर.
Okay, it's 10 p.m.
Sir, access system, sir.
Okay, Raja, it will take some time. Okay, where is the access system? Hide the draft. Okay, this one for this, Raja.
Yes, sir.
Okay, so Raja, simple ways So how to get a perfect parting line in one shot? Tell me which is the critical. You have defined the, you have defined,
No, no, sir, no parting line, sir. Sir, I have to put a sir access system on the
hmm.
circle of
Yeah, I got your
middle of.
point. I got your point. But tell me, you have defined the lifter direction. With respect to this lifter direction, which faces are critical for you to clear in lifter? Yes, which are the faces which are critical for you, where you are facing some issue? Raja, quickly. Others, what do you think? Which faces will be critical for you to clear in the lifter direction? Tell me, these faces are critical, yes or no? These are critical. Are you facing some difficulty?
Resting faces, sir. Upward,
Sorry, Ganesh.
upward resting faces.
These two.
Yes, sir.
Okay. Again, these two. Yes, this as well.
Yes, sir.
So to decide a lifter direction, I will consider these faces. That's it. Okay. So now I will need the middle of this face and the bottom face. Yes or no? I will need the angle bisector of upper face and the lower face. Then only we can clear it in lifter direction. Yes, Raja.
Yes, sir.
Alt IG, enter, extract Control 2, extract this, multi selection, this and the bottom one. Say OK. Center graph. Hide. Skip over here. Make it hide. I have this two surface. Let's put a line through this point and this point. Say OK. Let's extrude along this direction. Okay. Let's check is there an angle or not. Okay. Any geometry. This surface with this one 0 0. This surface with this one 0 0. Okay. Now take the middle point of this one. Before that, let's check what is the angle between this and this one. What is the angle?
0.8.
0.8.
Where will be the lifter direction?
Point.
Where will be the lifter direction?
0.4.
Perfect. I will take the middle point, take a plane, normal to curve passing through the point. Say OK. Both surfaces are planar surface, so I can take direct intersection. Double click. In first element, I will select upper surface as well as the lower surface. But in second element, I will select the plane only. I got to intersection. Angle will be same, 0.8 degree. Here you can see 0.8. Now, hide this one. A line bisecting of line 1, line 2, and the point will be this one. Tell me which option is correct, first or second?
Second.
Second. Say OK. You got this line. You can extend. Done. Now hide everything. Let's change the property. Now show the 3D. Now let's perform the draft ANSYS. Tell me what will the draft ANSYS value?
0.4.
Point 4.
Point 4. Point 4.
0.38.
0.38. Double click. 0.38 is okay. Tell me, Raja, is there an issue?
Sir, lower side is sir. That's why.
This blue portion is the issue. Okay, let me define this one. Now double click on the draft, show, double click, select the body, say okay. Yeah, I agree, Raja, there is some issue. Okay, so for this reason, your method is correct, sir. I will have to increase the angle. Okay, now you will increase the angle little bit like this. Perfect. Upside.
Yes, sir.
Now in this case, don't change this what we discuss. We will not change the upper resting face of the rib. Rest thing you can change. Anyhow, you are not going to clear the top face in lifted direction. It will be in MTD. Yes.
Yes, sir.
And by how much angle you are changing the value of this lifter angle?
1.5.
So 1.5 is very minor. No issue. Okay.
Okay, sir.
But don't change this resting. That's it. Okay.
Yes, sir.
Clear? Now, sir, how to add the access system? Yes.
Yes, sir.
We got lifted direction. Now how to add this one. Okay. How to find out the middle point? Please mute.
Is the circle.
Yes, Arvind, any blocking point?
Yes.
Yeah,
We
tell
have to
me.
create. We have to find out the center
Yeah,
point of that circle.
how to find out the center point?
1 second. Go to the
Point?
yes, point with the circle.
Point with circle sphere?
Yes.
Okay, let me cancel everything. Point, circle sphere, then
Select that one. Select that
this one.
circle. Yes.
What is the pop-up error?
No solution. There is no.
Okay, there is no solution for this operation. That means the selected edge is not a perfect circle. Okay,
Okay. Okay.
it is an arc. Okay, so how to find out the circle then? Take a point on this edge, middle point. I got this one. Say okay. I have one command in circle, 3-point arc, 3-point passing through 3-point. We have first point, we have second point, we have last point. I got one circle. Now can I use your method, a circle a point on
Yes.
circle sphere, this one. Say okay. Got it?
Yes. Actually, if you don't
Hmm.
mind, we go to that lifter concept.
Lifter concept, this one.
We have to consider any minimum or maximum angle in that case. It start clearing in 90 degrees with that MTD.
Hmm. No. There is no limitation.
Okay. And
The
you
hmm,
okay.
the main thing is what Raja mentioned, sir. This line is okay, no issue. But
Okay.
if you check the draft analysis, if I show the draft analysis, can you see the blue portion and the red portion in front of doghouse, this tower?
Yes, sir. Yes.
So can you imagine if you are sliding your lifter, it will move like this? Yes,
Lifter traveling, right?
yeah, lifter travel. So here
Yes.
we have some issue. This should be green, at least till this limit.
Yes. Yes.
Okay, so that's why Raja was trying to lift the angle little bit upward. If
Okay.
you
Okay.
lift the angle,
Okay. But
this will be green.
okay, that's okay. But my question is, we have
Hmm.
to maintain any
Angle?
angle
No,
considerations, or
no,
we
no,
have to free to.
no. There is no limitation.
Okay. And you make one 0.8 degree, right? We have to
Hmm.
consider that ribs surfaces.
Rib surfaces. I will maintain the top surface only, because why? Because the clip is going to rest on this rib. That's why.
That's okay. And
Hmm.
after that, we have to consider the bottom surface also. We have to find that angle between that rib surface and that bottom surface. It is a
This
0.8
bottom,
degree, right? Yes.
yeah, they are making 0.8 degree.
Then how we have to you consider at the 0.4 degree, right?
Hmm.
What is that concept? If you don't mind, please explain
Okay,
that.
what is that concept? Okay, I got it, got it. Okay. So, sir, why you have taken the angle bisector? Yes, Arvind?
Yes, 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 yes,
Okay, okay, no issue. So this is your, okay, let me hide this one. This is, I have find out the line this as a lifter direction, okay? So here, Arvind, the angle is very small, 0.5, so it is not visible in the
okay.
3D, okay? It is nearly straight plane. So I
Uh,
will draw a rough sketch over here, similarly on the top side, okay? Just focus on this one. So this is your bottom plastic part thickness, okay? Means this one.
uh,
Okay, on this one, you have a doghouse like this. You have some thickness. Now this face should be downside. This should be like this. This should be like this, again like this. Okay. Now
yes,
this will be the core out. Yes or no?
yes,
Now this is your, now so how you decided 0.4 degree for this line?
yes, yes,
Okay. What I measured? Uh, Arvind, if you remember, I selected for the angle. Okay, where is the angle? Sorry, we have not drawn the rib. Okay, let's draw the rib. Can you see this rib up? This
yes,
one and this one. I'm drawing the same rib. Okay, I will draw the same rib. So for now, I will just increase the angle for now. Okay, can you see this line of the top surface of that rib and the bottom? They are making some positive angle.
yes,
Okay, so if I design the lifter block with blue color, the lifter block will be something like, let let me design the lifter block over here first. It will be something like this: 1 2 3 4 5 6. This will be your lifter block.
yes.
I don't know whether it is visible or not. Shall I change the color?
No, no, it's visible. It's visible.
Okay, it's visible.
Yes,
Just a minute. Okay, so this will be your lifter block. Agree?
yes, yes, yes,
It is going to slide in this green direction.
yes,
So this face and this face should have a positive angle.
yes,
The positive angle is of 0.8 degree we measured.
yes, yes,
So
yes.
tell me, we want positive angle on both sides. So our lifted direction should be the middle line of these two.
Okay, okay. Yes,
Got it?
yes, yes, sir.
So this will be 0.3, this will be 0.3, sorry, 0.4 and 0.4.
Yes,
Can you imagine the red lines now? The angle
yes,
between
yes,
red line is 0.8 and white line, white color. I have drawn a angle bisector of these two red line.
yes,
That means we will create 0.4 degree with the upper face, zero point 0.4 with the bottom. So everything will be, so this will be the win-win situation. We are clearing upper as well as the bottom face. The common line will be the white line.
yes. Okay, okay.
Perfect.
Yes, yes, clear. Thank you.
Good. Everyone clear?
So then why 0.38? Why not 5.4?
0.38. Raja, Ganesh, if you are using 0.4 in draft analysis, CATIA will show you that surface in blue color. Yes, 0.4 will match with 0.4. For CATIA, it will be a neutral surface. That's why we will do draft analysis on 0.38, 0.39. Got it?
Yes, sir.
Good. Okay, done. Where is the MTD? Now, Raja, coming back to your point, sir, what is the angle between these two lines? In geometry, this with this one, 90 degree. Okay, but now Raja wants to lift this line by some reason. Okay, let's extrude this line in MTD. Done. A line, angle normal to curve. Curve will be this one. Support will be this surface. Point will be this line. What is the angle, Raja?
Sir, 1.5.
1.5 upside. Upside. Okay. So this is my new line. Let's change the color, make it green. Hide the surface. Hide this line. Now what is the angle between the green line and MTD? 91.5. Good. Now so how to put the axis system? Okay. Raja, tell me, will you insert the axis system with respect to this line or will you insert the axis system with respect to the white line? White line is 90 degree with MTD. Tell me, this line is applicable for complete feature or only for these faces?
Sir, inside this. Sir.
Only inside faces. Okay. So tell me, because of this inside faces, will you change the orientation of your axis system with respect to this line? Or can you, just now I measured the angle between white line and the MTD is 90 degree. Can you see the 90 degree? I will put the axis system. We discussed this point in our previous sessions. Okay. Point Y will be my MTD and Z will be my white line. Done. Tell me, Raja, this line you will use only for draft command. That's it.
Okay, sir.
Clear?
Yes, sir. Yes.
Now, if you notice, the orientation of compass and our axis system is also good. Here you can see the compass and the axis system. Correct? Now, can you design the complete tower on this axis system?
Yes, yes, sir. Sir, only for the draft, I go with a green line.
Only for lifter portion, the faces what you want to clear in lifter, just use this line.
Yes, sir. Okay, sir.
Clear?
Yes, sir. Clear.
Okay.
Sir, now clear that means that faces
Perform
with
draft analysis.
new lifter line.
Sorry.
Draft run means previously we saw the blue patches by using white lifter direction.
Yes.
But now after lifting that lifter direction upward, please sir, will you please sir check that draft analysis whether it is clearing that with respect to new.
This is green line, okay.
We have to increase sir that angle.
Can you see?
Yes sir. Okay.
Clear? The front portion of the doghouse is completely green.
Yes sir.
Okay, that's why Raja has lifted the lifter direction by 1.5 degree.
Sir, give that minus 1.5. Give that
the angle minus 1.5.
Yes, sir.
minus preview downside. Okay. Perform draft analysis.
Yes, sir.
Double click on this line. Compass. Everything is in undercut.
Okay, sir.
Okay.
Yes, sir. Sir, what is the maximum we can take angle?
It depends on your depth of the block. What is the depth of the block from this face till the inside one, this one? What is the depth? Nearly 25 mm. Yes, Raja,
Yes, sir.
25 mm. So the portion, this portion, 25 plus 10 mm. Let's consider safe side 10 mm. So 25 plus 10. This should be green. That's it.
Okay, sir.
10 we have kept just as a margin. Okay.
Okay. So angle up
Angle
to
can
that
be any. Angle
anything.
can be any angle.
Okay, sir.
Okay.
Yes.
Okay, then I think we can
Sir,
stop. Yes, Ganesh.
will you
Yes.
decide 1.5 degree value?
Raja, can you mention
Okay,
how will you decide the 1.5 degree?
Sorry, sir.
Ganesh, please repeat the question.
how you decide 1.5 degree to lift the direction?
By putting first one, then put 1.5. See the lifter travel length, the area the lifter travel. See there is no only green color is showing. So you can lift up to then check 1.5, then check 1 2 according.
Okay, Ganesh. See, if you're performing draft analysis with respect to the white line, you are getting some blue portion over here. Remember, Ganesh? Red and blue.
Yes, yes, sir.
Okay, we have some blue portion and red portion in this area. Then what we'll do, white line is not working, but white line will be my reference. Now let's lift the line by 0.5 degree. Okay, try and error. Now the blue line will shift over here. Red line will shift over here. Are you getting, Ganesh? Okay.
Yes, sir.
So means what we have done, we have reduced the blue portion. We have reduced the red portion. It is moving front. Now 0.5 is also not working. Let's make the angle 1 degree. Now once we change the angle 1 degree, again it will move like this. Red will move forward. Yes, Ganesh.
Yes, sir.
Now on 1.5 degree, again this is also not working. Let's increase the angle by again 0.5. So total angle is 1.5. Now if we check, you are getting this result. Got it? Yes
Yes,
or
sir.
no? So it is try and error method. Clear?
Show the depth, how you measure depth.
How you measure the depth? Simple. Take the section. This will be the depth. The front face and the maximum rear, extreme rear face. Take any geometry for the front. This face, sorry, any geometry. This face, any geometry, last face. This is the last face, yes or no? Or shall I select this one? This is the extreme last. What is the length? 24.7. Clear? Let's consider 25. So your block will move front side 25 plus 10 mm extra, safe side. So once you open the tool, your block will be something like this. See, 10 mm will be extra, means it will be something like this. Can you imagine, Ganesh? So what is 10
Yes,
mm?
sir.
10 mm means this one, extra 10 mm, safe side. Can you imagine if your white block is moving inside, it will fit over here? Yes or no?
Yes, sir.
And so which portion should be green? From this end till this end should be the green base. The B side surface should be green. Got it? That's why Raja has increased that angle by 1.5 degree. Clear? There should be no blue or red patch. Otherwise your
Yes, sir.
lifter will damage your part. This block will damage the lower base surface. Perfect. Good discussion.
सर वो एक बार वो कमांड थोड़ा एक्टिवेट करके दिखाएंगे क्या सर, वो डिजाइन
Which
मोड
one?
और विजुअलाइजेशन मोड?
Okay. Now here you can see the part is in design mode. So how to identify? If you select any patch, there is no meshing. That means this is in design mode. If I right click, I don't know whether it will work in reverse direction or not. Let me check. Visual mode. Switch in visual. No, it is not working. Okay.
Okay.
Not going back to the visual mode, but if I close the complete product, let's close the complete product. Close this as well. Raja, do you want this file or will you do it on your side?
No, sir.
Okay. Let's close this file as well. File, open the product. See this, we have all part, but can you see there is nothing on my screen?
Yes.
So suppose I want to see this part, right click, representation, activate terminal node. I got the 3D, but this is not the 3D. This is only 3D representation. I can't edit this one. Can you see if I select any surface, can you see the meshing, the hashing lines?
Yes, yes.
Any face you can select on this side as well. Can you see the meshing? That means
Yes.
this is only in visualization mode. You can't edit this one. But
yes, sir, I got this. But these options are not showing in my CATIA,
you have
not
to
in
do,
my office
okay.
system as well.
No, it will not be visible. You will have to do some settings. In tools options, you will have to do some settings. Then only you can activate or deactivate the visualization mode and design modes. What is the benefit of this one? If suppose if you're opening any product, let's say a complete set or a complete dashboard, if you're opening or complete door panel, there the size of the product will be 3 GB, 4 GB, including kinematics, all motions and all. Surfacing, sketches, parts, 3D, dump surface, everything. The size is nearly 3 to 4 GB. If you are not activated this setting, if you are not done this setting, the product which you are trying to open, it will take 20 minutes, 30 minutes to open.
Yes, correct.
Okay. Now tell me, I'm not working on this part. So why should activate this part? No use. I'm just working on the one part. So I will just right click on the single part, say design mode. Now I can work on it. Okay. But suppose, sir, I want the reference. You can just right click and say represent. You can just right click and you can say representation. Sorry, active terminal node. That's it. Okay, show this one. But if you want to edit, just say design mode again. You can hide it. So what will happen? It will not consume your computer or the system power, the RAM power, the graphics power. Okay, you can work in high speed. Okay.
Yes.
That's why you have to do some settings. Okay, it's 10:30. I think we can stop. Please continue your project work. If you have some blocking point, Please save your file. You can share in next session. I will make some corrections. No issue. If you have some technical blocking point, please note it down. We will discuss in next session. Okay. Done?
Yes, sir. Thank you, sir. Good night.
Okay.
Yes.
Thank you. Bye. Good night. See you in next session.
Good night.
Good night, sir.
Good night all.
Good
Bye.
night, sir.
Good night.